Hey everybody, it's time for the first grade math unit 3 just-in-time training. I hope that you find this helpful as you plan for your unit 3 instruction. Let's start today by talking about 1 and BT3. In unit 3, first graders are continuing their work with comparing two two-digit numbers based on the meanings of the tens and ones digits. In unit 3, we add in the use of the symbols greater than, equal to, and less than. It's important to understand that this is as much about developing the language as it is about the appropriate use of these symbols. Students need not only to be able to place the appropriate symbol between two numbers, but then to also be able to read the mathematical expression that they've created. For example, when given the numbers 23 and 42, the students should be able to fill in the less than symbol, but then they should also be able to read the expression 23 is less than 42. With the numbers 37 and 19, they would use the greater than symbol and be able to read the expression 37 is greater than 19. Oftentimes we focus so much on getting students to place the appropriate symbol that we don't necessarily develop their understanding or develop the language and the names of these symbols. Students often will visualize symbols such as these, like an alligator or a Pac-Man, where the Pac-Man eats the greater number, and sometimes that can cause them to always think of the statement as a greater than statement. 42 is greater than 23, and never really develop the language 23 is less than 42. One way around this, or another way to introduce the meaning of these symbols, is to think of the symbols with dots on their end. If you place one dot here on the end and one dot here and one dot here, students can see that there are fewer dots on the left, or less dots on the left, and greater dots on the right. So as they read this expression from left to right, they read 23 is less than 42 because the first side that they come to is the side with less dots than the other. Likewise, they would read this expression, 37 is greater than 19, because the side that they look at as they read from left to right has the greater dots. Developing this language based on the features of the actual symbols rather than cartoonized symbols or characterized symbols will help students as they get into upper grades and higher levels of mathematics, when they have to be able to use these symbols as solutions to their algebraic equations. Problem solving continues in Unit 3 with the addition of a few new problem types. Remember that you are always welcome to increase number size for your students who are ready, but first graders are only expected to master problem solving within 20. So if you are increasing the number size and students are struggling with that a bit, that's okay, because of the standard for mathematical practice, persevere in problem solving. But remember, again, for their report card and for assessment, they only have to master in first grade problem solving within 20. Let's take a look at the table on page 2 of your curriculum map to see the problem types that we're introducing in Unit 3. In Unit 3, we're introducing the compare problem types, except for the two problems here that are shaded in white. Those two problem types are introduced in Unit 4. Let's talk for a minute about why those problem types are excluded from Unit 3. This problem here, the version with fewer, is a difficult problem for students because it gives us the amount that Lucy has. Lucy has 3 fewer apples than Julie, and Lucy has 2 apples. Now it wants us to find out how many apples Julie has. The word fewer here triggers a desire to subtract. However, because we know how many Lucy has, and we know that Lucy's is 3 fewer than Julie's, we actually would need to add to find out how many Julie has. So the word in the story triggers the opposite operation that we actually should probably use to solve this problem. Likewise, this problem here has a similar situation. Julie has 3 more apples than Lucy. Julie has 5 apples. How many apples does Lucy have? The word more in this problem situation triggers a desire to add or to use the operation of addition to solve. But because we actually know how many Julie has, and we know that that's 3 more than what Lucy has, we actually should be subtracting or finding the difference between these two amounts. So again, because the words in the story trigger the opposite operation from what needs to be used, these are some of the most difficult problem types that we can give to students. So when introducing compare problem types to your students, be careful to avoid these 2 problem types at first, and give only the ones where the word in the story triggers the appropriate operation. With these 3 standards, I want to take a minute to talk about students' use of properties as strategies to add and subtract. In particular, we're going to focus on the strategy doubles plus 2, which is the new strategy for this unit with regards to Standard 10A6. This is a number string that has been written to elicit the doubles plus 2 strategy. The intention is that if you first put up 7 plus 7, students will naturally know the double or will already have the double known from memory from work in previous quarters. Then you put up 8 plus 7 and they will recognize that that is just one more. Then next would be 7 plus 9 and they would recognize that that is simply 2 more than 7 plus 7. Recording a student's thinking on 7 plus 9 might look something like this. First, I thought of the 9 as 7 plus 2, and then I added the 7 and 7 because I just knew that was 14, and then I took 14 plus 2, and I got 16. This is a great way to record the students' thinking, and it's important to record students' thinking the way that they say it in order to make connections to how they're solving the problem and to help other students in the class see how they're solving the problem. In addition to recording the students' thinking, it's also important to record mathematical notation as you continue the discussion. For this one, it would look something like this. First, I thought of 7 plus 9, and that is the same value as 7 plus 7 plus 2. Then I reassociated 7 plus 7 plus 2, and that was 14 plus 2, or 16. When recording the mathematical notation behind the student's thinking, it becomes more obvious which property is at the root of their thinking. In this case, it was the associative property. Remember, it's not expected that students be able to notate their own thinking in the formal mathematical way. However, it is important that we as teachers show them this notation as we discuss their thinking. This is how they will come to learn it, and you may be surprised at which students are able to pick up this notation and use it on their own. 16 minus 9 is a related subtraction fact that should be focused on in this unit. And while some students may be creative in using a doubles type strategy with the subtraction fact, it's more likely that they will use 10 as a benchmark. Recording their thinking might look something like this. I started with 16 minus 9, and first I took away 6. 16 minus 6 equals 10. When you ask the student where the 6 came from, they might say it came from the 9, so you could then show the decomposition of 9 as 6 plus 3. Then, once they took away the 6 to get to 10, they have 10 minus 3, and that equals 7. Recording the mathematical notation for this one is a little tricky. It might look something like this. 16 minus 9 is the same value as 16 minus 6 plus 3 is the same value as 16 minus 6 minus 3, which is 10 minus 3, or 7. This mathematical notation may appear to be confusing for students because at one point you have an addition symbol which turns into a subtraction symbol. This is technically showing the distributive property of multiplication over addition, but I wouldn't get into that with your first graders. Instead, you may choose to simply show them this notation starting with 16 minus 6 minus 3 equals 10 minus 3 equals 7, and have them determine where they can find the 9, and they might notice that if you take away 6 and take away 3, you're taking away 9. Standards 1087 and 1088 are very closely related. 1087 is building an understanding of the meaning of the equal sign and working with true-false number sentences, and 1088 is using that understanding of the equal sign to complete an equation to find the missing addend or the missing number that makes the statement true. When developing an understanding of the meaning of the equal sign, I know I have often referred to the equal sign using the words same as. At this point, I must say that I reserve the right to disagree with myself. I have come upon some new learning from the National Council for Supervisors of Mathematics that might help us to develop a better understanding of the meaning of the equal sign. This statement from NCSM says that defining equality as the same as is a problem because it is mathematically incorrect and leads to misconceptions. Their suggestion is that instead of using the same as, we should use the words same value as. For example, 3 plus 4 tells a different math story than 4 plus 3, meaning that if I have 3 apples and I'm given 4 more, that's a different story than if I had 4 apples and I'm given 3 more. But the two expressions, 3 plus 4 and 4 plus 3, yield the same value of 7. You may have noticed as I was talking through the mathematical notation for the problems we solved earlier that I was using the words same value as rather than the words same as. Just something to think about, courtesy of the National Council for Supervisors of Mathematics. While this may not seem like such a big deal with addition story problems, it does cause some hindrance with multiplication in future grades when students think of 3 groups of 7 and 7 groups of 3. Definitely not the same math story, yet they yield the same value. The last standard on your curriculum map for Unit 3 is 1MD3, telling and writing time. In Unit 3, we are now telling and writing time to the nearest half hour. Remember that telling time is not a critical area of focus and is therefore a supporting standard. With half hours, this standard ties nicely into your Unit 2 standard 1G3, which was partitioning circles into halves and quarters. For example, with a picture like this one, you could talk about the minute hand going halfway around the circle. The time is half past the hour, 30 is half of 60, etc., as you work on the student's ability to tell time to half hours. Well, I think that's all I've got for Unit 3. Again, I hope that you find this helpful as you plan your Unit 3 instruction.